Hey folks, how's it going? This is Mr. Murray coming to you with a video on arc length and sector area. Alright, so in this video I'm going to talk to you about these two subjects, and these are going to be a little bit of extension on circles. So up to this point we've seen that we can calculate the area of a circle, right? If we're given a radius, we know that the area is equal to pi times the radius squared. And we also know if this is the total area, and we know that if we're given the radius, we can also find the circumference because it's 2 times the radius times pi, or in other words, the diameter times pi. But now what we're thinking about is, what if we don't actually have an entire circle? What if we only want to know a piece of the circle? Okay, so to motivate this, I started by looking at this piece of pi. All right, and as our buddy Homer would say here, pi, right? So here's our pi. You can imagine we have this piece of cherry pie, and someone's gone and they've taken a cut out of that pie, right? They've sliced a piece out. All right, we can look at the stuff in the middle, right? The piece in the middle here. Then we could view this as what we'd call a sector or section, right? When you think sector, maybe think section. Okay, maybe when you look at circles and we start to talk about them, you can think about it as taking a piece of slice of pie out of the entire thing. And then we also have the crust, right? The piece that lays around the circumference, right? Now we don't want the whole circumference, only a piece of it. And that piece of the circumference is called the arc. Okay? Now, this is how we define these things. And if you might know that the total number of degrees in a circle is 360 degrees. Now, I don't know if you learned about this before, but the definition of a degree, well, that is 1/360th of a circle. So you can imagine taking a circle, you can imagine cutting it into 360 equal pieces, and each one of those pieces represents a degree. Now, degrees are pretty arbitrary, and we may talk about another measurement for angles later on, because like with degrees, it's pretty arbitrary, right? Why 360? You know what I mean? That's like, why that number? Why not 720? Why not 180? So we'll talk about that hopefully. But in this video, our goal is to figure out a couple things. One, based on the angle, right, at which I cut this piece, how much pi did we actually get? And how much crust did we actually get? Okay? So throughout this video, there's going to be examples for me to do, us to do, and you to do. And I really hope you take the time to work through this, because I think you'll find that it might start off a little bit difficult and confusing, but by the end of it, you'll actually be able to kind of crank through these problems pretty easily. Okay, so I'm going to get started with one for me to do. Now, to introduce some notation here, okay, we need to find the arc length and the sector area. Now, I'm going to define pi to be about 3.142. We know it's about 3.1415. So I'm going to round it to 3 decimal places. It's not something you usually see. You usually see it rounded as 3.14. I'm choosing 3 decimal places because I want to make my results a little bit more accurate. I'm going to show them to you in terms of pi, which is an exact answer, and in terms of when I substitute so you can get an approximate answer. Okay, so when I ask for the sector, let me get this in yellow. I'm talking about this piece here. This is my piece of pie that you saw me colored in. We call the sector AOB. Okay? It's written just like an angle would be written. Okay? And it's written such that it doesn't matter. You can call this BOA or AOB, but what matters is the second letter needs to be the center of the circle. So you can think about it like this is like an angle, right? So if this was angle A, we'd mark it such that the middle letter represents the vertex of the angle. So it's a similar idea. And then we call the arc AB like that. Okay? So here we go. Our goal is we want to figure this out, and we want to know what's going on with this particular arc. So to start, what we have to think about is this. Well, we know that a circle, right, the total number of degrees is 360 degrees. So we know this is 120 degrees. So what I'm going to do is this. Well, I'm going to take the number of degrees in this piece of pi, and I'm going to divide it by the total number of degrees in the circle. And what that gets me is 120 over 360, which is a third. So because this 120 is a third of the total angles of a circle, which is 360, this area, and again, I'll do this. Let me choose a little bit. I'll choose this nice orange here. Okay, this area is going to be a third of the total area, and this red arc is going to be a third of the total circumference. So what we now need to do is calculate the area. So if I've got 7 inches as the radius, my area is pi times 7 squared, also known as 49 pi. So if this is a third of the total area, then the sector area I'm looking for, so we call this the area of AOB, is equal to 1/3 of, right, the total area, 49 pi. Okay? In other words, we could look at this as 49 pi divided by 3. That would actually, to me, if I ask you for an exact answer, to me, that would be an acceptable answer, because 49 is not divisible by 3, so there's no way you can simplify that really. So now what I'm going to do is I'm going to plug in 3.142 for pi, and I'm going to get an approximate answer. So I'm going to do 49 times 3.142 divided by 3. And I'm going to choose to round to the nearest hundredth. So what I'm going to write is it's approximately 51.32. And again, remember, we're dropping in about 3.142. Remember the units, because I gave you units, you'd report inches squared, or you could write SQIN. I would take that as well. So that's our area. What about our arc length? So to do the arc length, I need to know the circumference. Well, that would be 2 times pi times the radius. And so the 2 and the 7 multiply to get 14 pi. So now if I want to know the arc length, we call this the measurement of AB. Well, that's equal to 1/3 times, right, because 120 is a third of the 360 total angles. The measurement of the arc is a third of the total circumference, which is 14 pi. And this simplifies similarly as 14 pi over 3 inches. That would be an exact answer. Now, if I go ahead and I'm going to, on my calculator, unfortunately, my trial for the TI Smart View is up, so I'm going to have to do manually. 14 times 3.142 divided by 3. And what I get is 14.66. Inches. Okay, so here's the general breakdown. Step 1, you need to figure out what percent of the, or fraction of the total degrees is represented by the given degrees. That's step 1. And that gives you this magical ratio. You then, 2, calculate the total area. Remember, this is our area. This is our circumference. And then step 3, you use that magic ratio to figure out, based on 1 and 2, you take the ratio, you multiply it by the area. That gives you the sector area. You take the ratio, you multiply it by the circumference. That gives you the arc length. Okay, so please make sure you understood what I did here in this example. All right, I will have another I do coming up, but please make sure you understood what I did here. And then in a moment, I will move on to another one that I'll work through so you can see it, another example. Okay, so this is going to be a similar problem. So here, what I want to find, and again, we call this arc, be very careful, BAC, rather the sector is called BAC, and I'm going to call the arc BC. Okay, versus I feel like CB, if I said CB, you might get confused and think you were going this way. I like to go clockwise like a clock. Okay, but if it was a quiz or a test, I would try to be more clear as to what was going on there. Maybe by sometimes, and you'll see they put it on the outside. So make it a little bit clear what they're talking about. All right, so remember the first step we want to do is we want to say, hey, look, I know that there's 360 degrees in a circle. What fraction of the total degrees does 30 represent? So I take 30 and I do that divided by 360. And what I get, well, 3 goes into 36 12 times. So I get a 12th. So remember, what does that mean? That means that this arc is a 12th of the entire circumference. Okay? And this sector area is a 12th of the total area. And what's cool, right, is that this feeds into some of the stuff we've been talking about, right? We spent a lot of time in the trig talking about proportions and setting up proportions and solving proportions, right? We talked about that in similarity as well. So there's also a lot of proportionality here too, right? How, because a 30 is a 12th of 360, this is a 12th of the circumference, the area is a 12th of the total area. So let's figure out what that is. Now, I really haven't given you enough information here. So I'm going to say, let's say this is 6 centimeters. You would need to know something like that to be able to solve this. Okay, so step 2, let's figure out the area. So the area is equal to pi times 6 squared, and 6 squared is 36. So the area is 36 pi. At this point, we actually do want to leave pi in the answer. Circumference is equal to 2 times pi times 6, which is equal to 12 pi. Now, the fact that it's a third of the area, that's just a coincidence. I wouldn't look too much into it. There's no real rule there. All right, if you want an example, right? This 14 was not a third of 49. Okay? So here's step 3. We now need to find each thing at a time. So the area of the sector is equal to 1/12 of the total area, which is 36 pi. And if we do that, well, 36 divided by 12 is 3, so we get 3 pi. And if we substitute, and rather that's 3.5 pi, and we really should put our units here. These are centimeters. Let's do that in blue. Centimeters squared. Centimeters squared. That's pretty important. So we'll do 3 times 3.142, and I get 9.43. So you could do it exactly as 3 pi centimeters squared, or you could do it as about 9.43 centimeters squared if I ask you for an approximation. Okay, and then we have the measurement of the arc. and that's equal to 1/12 of the total circumference, okay? Because 30 is a 12th of 360, so you get that proportion. And that's nice because a 12th of 12, right, that's 1. So it's equal to pi centimeters, or in other words, about 3.142 centimeters. Okay, so that's how it works. We essentially get the ratio of the angle that's associated with this piece to the 360, the total, and then we calculate all of the area and all of the circumference, and then we use that ratio and multiply it by the entire area to get the sector area, and then by the entire circumference to get the arc measurement. That's basically how any of these problems works, okay? So please make sure you understood what I did here, rather, as well as the last one, okay? And then when you're ready, I'm going to start to turn up the heat a little bit, and maybe we'll move in some ones for us to try. All right, so here's one for us to do. So I have to find the area of DEF. So specifically, we do have to be careful here. I don't want to know this piece. You can see by the arc, I actually want to know this piece. Okay. Now, I put the 216 on the outside, and the reason I'm doing that is because I do want you to get used to multiple different notations. In the book, they might show you it with the outside. Sometimes they'll show it to you with the inside. It doesn't really matter where you put the degrees. It has, as far as I can tell, the same exact meaning. Okay. So what do we start with first? The first thing we'd have to do is do what? We'd have to take 216 and, not A. We have to take 216 and divide by 360, right? We have to get that special ratio. So I'm doing 216 over 360. Nice, and I got 0.6. Or in other words, if I was not even squigglies, okay? That's equal to 3/5. By the way, if you're on a calculator, here's a little hack. If you press the math button and then you do 2 frac, that's the first option. It will take, what will happen is you'll see on the next line, it'll go ants 2 frac. And if you hit enter, what it does is it takes the last thing that was put into your calculator and it converts it to a fraction. So I just did that, and I put in 0.6, and my calculator gave me 3/5. So that might be something that's helpful. Okay, step 2. What do we need to do now in step 2? We need to find the entire area. Now to do that, again, I do need to give you some piece of information. I'm going to throw a curveball here, so to speak. I'm going to make this a dotted line. I'm going to make it a red dotted line. I'm actually going to give you the diameter, okay? I'm going to turn this one up a notch by giving the diameter. So I'm going to make that just a little bit thicker here so you can see that it's the diameter. And I'm going to tell you that the diameter is 20 meters, okay? Just because I'm feeling a little bit creative. That should be in red. Okay, given that it's 20 meters, okay, first of all, how do we find the area? So the area is equal to pi times 10 squared, not times 20, because 20 is the diameter. I want the radius. So 10 squared is 100, so it's equal to 100 pi, or approximately 314.2. Okay, the circumference is equal to 2 times pi times r, but we can actually look at it as the diameter times pi. Okay, that's another way to look at it. Okay, because essentially if I cut it in half to find the radius, I'm just doubling it again to get the final answer, so I'm just going to save myself time. Okay, and then remember, please use units. This is meters squared and meters. Okay, step 3. I'm going to take the area first. I'm going to do what with it? I'm going to multiply it. Hopefully you said multiply by what? 3/5. So 3/5 times 100 pi. That's going to give me the area. So let's mark that as area of, and we're going to call this, I'm going to call this DEF. Okay, so 3/5 of 100, that's 60. So we get 60 pi. And if I'm going to estimate, I'll do 60 times 3.142. And that gives me, so that's meters squared, which is approximately, and I'll just go ahead, just come in here real quick and just, it's approximately 188.52 meters squared. All right, now what we got to do is, it's now time to find the measurement of DF. Okay, so to do that, we're going to start by multiplying what? We're going to do our 3/5, and we're going to times it by what? 20 pi, because that's the total circumference. Okay, so when I do that, I get 3/5 of 20, and I can do that on my calculator, and that's 12, so I should get 12 pi meters. And if I want to do an approximation, I would take 12, and I'm going to multiply it by 3.142, and I get about 37.70 meters. Now, in terms of the 3.142, if I'm asking you to approximate, I would, like, if this is like a textbook problem, I would just look carefully as to what they're actually asking you to approximate pi to. The book so far has asked you to do 3.14, so just please respect whatever they're asking you to use for pi. If this was a quiz or a test and I didn't specify, that's obviously something you would ask me. But I don't think I'm going to nitpick as to whether you say 3.14 or 3.142. 3.141, that might be a challenge because that's not really a correct rounding. But that's not really my main concern at this point, okay? So again, steps 1, get the ratio of the degrees from the angle, or rather from the arc, to the total degrees. So that was 0.6 or 3/5. Step 2, calculate the total area and the total circumference. Step 3, multiply the ratio by the total area to get the sector area. Then multiply the ratio times the total circumference to get the arc length. The order you do it doesn't matter. This is just the order that I chose to do it. Okay, so please make sure you understand what I did here. And then when you're ready, go ahead and I'll move on in a moment to the next question. All right. So I thought here what I would do is I would start to show you a few more examples of what it looks like in the book. Now, in the book, they're pretty adamant in terms of asking and showing you things like this. So here, they're asking you to find the arc length. Okay, what they're saying is, imagine that I drew this here, and all radii are the same. So whether the radius is here or here, right, this is 30. Doesn't really matter. They're saying pretend it's the same as saying that this is 90 degrees. So again, where you put the arc does not matter. We're just now trying to find only the arc length. So this is just a little bit more straightforward. So step 1, well, look, we know this is 90, and actually we could even look at this in theory, right? This is a right angle. So what fraction of the total angle of a circle is this? So I do 90 out of 360, and that's equal to what? It's equal to a quarter, okay, or 0.25. So because the angle represents a quarter of the total circle, this arc is going to represent a quarter of the total circumference. So let's find the circumference. So the circumference is equal to 2 times pi times r, which is 30. So it's equal to 60 pi meters. And now what I'm going to do is, well, I want a quarter of that, right? So I'm going to take my ratio that I found, a quarter. I'm going to multiply it by 60 pi. And what that gets me is 15 pi, right? Because 15 is a quarter of 60 meters. And let's do a little bit of approximation. So I'll do 15 times 3.142. And that gets me approximately 47.13 meters. Okay? So please make sure you understand what I did here in terms of the problems. Okay? And then when you're ready, what I'm going to do is I'm going to go ahead and move on to the next problem. All right, so another one for us to do. Here, notice I only want the sector area. So I'm kind of like going from ones where I do both, and now I'm kind of trying to break it down in terms of ones where we each practice doing one at a time. Okay, this is going to be my last we do, and then I'm going to turn it over to you. All right, so sector area. So sector, remember the sector is called maybe A, B, C is our name of the sector. So first step, what's our first step? We're going to do what? We're going to do 20 divided by 360. Okay, remember the 20 being here does not matter. So I do 20 over 360. Now, on my calculator, I get 0.05555555556. If you have a graphing calculator, hit math. Look at option 1 to frac. Enter. And what your calculator will do is it will show you the output 1/18. Do not use 0.555556. Don't do that. Only use a decimal if it's like 0.25, 0.125, 0.875, 0.50, something like that where it terminates right away. Never use 0.33333 instead of a third. Don't do that. That's not right, because if I do that, the 0.55555555, if I cut, as soon as I cut off a decimal, right, what that's doing is that's approximating. So I'm not getting the exact answer anymore. I'd rather you use 1/18, and I'm giving you the calculator to help you get that. All right. So step 2, what do we need to know in step 2? We need to find the total area. So the radius is 2. So area is pi times 2 squared, okay, which is 4 pi square feet. Hopefully in the last one, I'm just shoot back to this one. Nice, we put our units there. Okay. 4 pi feet squared, or 4 pi square feet. So step 3, what are we doing in step 3? We're doing what and what? We are doing 1/18 times 4 pi. Okay, so we're going to do 4 divided by 18. Okay, that's going to give you 0.222222222. So let's do our 2 frac scale. And the calculator says that's equal to 2 over 9 times pi feet squared. If I want an approximation, I just hit times, and you can see it plug in your answer, 3.142. And that gets me approximately, let's do 2 decimal places, 0.70 feet squared. Okay? So again, taking the degrees over the total, calculating everything, then multiplying that ratio by the total, and that's going to get me my answer, making sure we put in the units. Okay, so again, please make sure you understand what I did here. Okay, and then when you're ready, I'm going to go ahead and move on to our first problems for you to try. Okay, so 2 tries. So I took this closely from the book. As you can see, I did a little bit of marking this up. So I've enhanced this. The book breaks it into 2 sections. The first section is only arc length. The second section is sector area. I'm combining them because I think it's a skill we can do both at the same time. Okay. So what I'm going to do is this. What I want you to do is this. You have 110 as your angle. You have 48 as your radius. What I want you to do, I want you to calculate the length of the arc and the sector area. You need to enter your answer in terms of pi. So write one where we leave it as pi, and another one where you round it to the nearest tenth. In this case, I'm going to say, let's let pi equal 3.14, and we'll round to the nearest tenth. Okay, so what I want you to do, pause the video, find the arc length, AB, and the area of AOB, give it to me in terms of pi, and round it to the nearest tenth, and then when you're ready, unpause, and I'll show you what I got. Alrighty. So, let's get started with this one. So basically, I want to calculate this area, and what I want to do here is I first need to take 110 and divide by 360, right? I got to get that magical ratio. So I'm doing this on my calculator right now. I get 0.305555556, so I'm going to convert it to a fraction on my calculator. And the best I can get is 11 over 36. And that kind of makes sense if you cancel the zeros. Step 2, I want to calculate both the area and the circumference. So the area is equal to pi times 48 squared. You have to use your calculator for this. On my calculator, I get 2304 pi. Circumference is equal to 2 times pi times r, in this case 48. So it would be 96 pi. This is something I would definitely give you a calculator for if I was giving you this difficult of calculations. Obviously, if I was to tell you no calculator allowed ever, I would have to adjust the problems accordingly, right? And I've always done my best to be fair with you guys about that. I've done my best to give you problems where if I don't give you a calculator, then I'm going to adjust the difficulty of the problems so that you have, you can't need a calculator to solve it, right? I try to be fair. Whether I'm fair or not, we've debated that this year, understandably. So first I want my area of AOB. So I'm going to take 11/36. I'm going to multiply it by 2304 pi. And remember, this is meters squared, and this is meters. So I do 11 times 2304, and then I divide by 36. And what I got was 704 pi. So that would be my exact answer. Now I'm going to take 704 and multiply by 3.14. I'm going to use just 3.14 here. And so what I get is it's about, remember this is meters squared, it's about 2210. They want nearest tenth. So I got 0.56. I'm going to call that 0.6. Now, if I take 704 and I do by 3.142, like we've been doing before, that is going to get you a slightly different answer. I got 2211.97, actually becomes 2212. So it is a little bit different, and so that's why you just got to be careful with regard to what we are defining pi to be. Okay, so I would say start with 3.14. If you're getting the wrong answer, I don't think you need another space than that. So on the homework online, maybe start with 3.14 and see what happens. Remember, I just added 3.142 to get a little bit more accuracy. So I'm going to report out 2210.6. And remember, I just didn't rewrite pi because pi was there. Alrighty. Now, I need to figure out the measurement of the arc, AB. So what do I do? I take 11/36. I multiply it by 96 pi. So that's 11 times 96 over 36. And what I get is 29. So that's equal to 29 1/3. So let me see if I can do that as a 2 frac. Okay, I'm going to convert that. So when I do it and I simplify it, my calculator tells me it's equal to 88/3. That's the 96 times 11/36 pi. And so what I'll do is I'll just take the pi and put it up top. Meters. And also make sure here you put your meters squared. Okay, and so we'll convert 88 times 3.14. Divide that by 3. And what I got is approximately, to the nearest tenth, 92.1. So I'd report 88/3 pi and 92.1 meters. So a little bit more difficult of a problem. I guess we call that, yeah, this is part of step 3. So you can call this 3A and 3B. So a little bit more difficult of a problem, but the same idea. You determine the ratio of the inner angle, or the angle that represents this little slice, to the total of 360. Right? Get that ratio. You calculate the entire area, entire circumference. Then you multiply that special ratio by the whole area to get the sector area. You multiply the ratio by the entire circumference to get the arc length. And every problem goes just like that. Okay, so again, please make sure you understood what I did here. Okay, and then when you're ready, I'm going to go ahead and move on to a last problem for you to try. All right, so same kind of problem. Here I want us to round to the nearest hundredth. I'm going to again define let pi equal 3.14 approximately. So I want you to find, again, two things. First, I want you to find the area of sector. And again, notice how the second letter is the middle. So the sector RST, I want the area. And then, again, in terms of a fraction of pi and the nearest hundredth, so one with pi in it, 1 to the nearest hundredth. And then I want you to find the length of arc, RT. Okay, so again, what I want you to do, pause the video, find those informations, and then when you're ready, unpause, and I'll show you how to solve. Okay, so here we go. Let's start with one step at a time. So I'm going to take, the first thing I'm going to do is I'm going to take 47 and I'm going to divide by the total of 360. And I'm going to immediately on my calculator convert that to a fraction. And it looks like there's actually no way we can simplify this any further. So I'm going to leave this as 47/360. It's not great, but it's kind of the best I can do right now. There's just no way to simplify. Okay, step 2. I'm going to now, that's what makes this one tough. I'm now going to do the total area. So area equals pi times 6 squared. 6 squared is 36. Circumference is equal to 2 times pi times r, or 2 times pi times 6. That's 12 pi. And now, I'm just going to wall this off. Step 3. Okay, to get the area of RST, I'm going to do, well, 47 3/60 times 36 pi. So 47 3/60 times 36. Okay. And what I get is, right, because this will cancel. This will be a 10. This will cancel and become a 1 if you think about simplifying fractions. So I get 4.7 pi. And by the way, these are feet squared and feet. So it's 4.7 pi, or 4.7 times 3.14. Or in other words, and we want nearest hundredth. So it's approximately 14.76 feet squared. So for the area, I put 4.7 pi. And you could do it as a fraction. You could really do it as, so if you want to be technical here, I think what they're looking for you to do is 47 over 10, technically speaking. So keep that in mind. If I don't, personally, if this is me on a quiz, I don't care if you're at 4.7. Personally, unless I specifically say a fraction, I don't see why I would. I personally don't have a problem with 4.7 pi. I'm just saying the online system might get picky with you. Okay, and then for our approximation, 14.76. Finally, to get the arc length, I'm going to do 47 3/60 times the total circumference. And we know the total circumference is 12 pi. So I'm going to do 47 over 360 times 12. That gets me 1.566667. I'm going to try to convert it to a fraction on my calculator. Okay, so when I convert it as a fraction, I get 47 over 30 and add the pi. Why does this happen? Because the 12 will cancel as a 1, and then the 12 goes into the 360 30 times, so we get that. So I would enter 47 over 30 pi. And if I want to know that as approximation, I'll do 47, I'll multiply it by 3.14, and divide by 30. So this would be feet, and I'd get approximately 4.92 feet. Okay, so folks, hopefully you found this video to be helpful. Hopefully this was really able to give you a sense of what's going on in terms of arc length and sector area. Hopefully you were able to find that this was a relatively straightforward idea, but again, it goes back to this. We have a whole entire circle, right? Our whole entire pie. And I want to know information about just pieces of the pie, whether that be, right, the part that I'm going to eat. I'm not a big fan of crust, or just the crust, right? So we know now that if we can figure out the angle here, and we can figure out its proportion, right? Or rather its ratio to the entire 360 degrees, then we know that proportionally, well, the area of that slice is going to be the same ratio or the same amount of the entire area, right? So when we had, this is an example, when the angle was a quarter of the total number of angles, the sector was a quarter of the total area. The arc was a quarter of the total circumference, and everything works out really proportionally like that. All right, so thanks very much for watching. Hopefully you'll take some time to think about any questions you might have and maybe ask those questions at a Google Hangout or send them to me by email. There will be a worksheet to come so you can have practice, but keep it up. Don't forget to love math, and remember, you can do it. All right, thanks so much for watching, and I'll see you next time.